Why can't any process be 100% efficient in thermodynamics? Imagine trying to get all the energy you put into a machine to turn into useful work without any waste at all. Sounds perfect, right? But in real life, it just can't happen. That's because of some fundamental rules about how energy works. The first law of thermodynamics tells us that energy cannot be created or destroyed, only changed from one form to another. So, if you burn fuel in a car engine, the chemical energy turns into heat and motion. But it doesn't mean all that energy becomes useful work. Some of it always turns into heat that disperses into the environment. Now, the second law of thermodynamics comes into play. It says that in any energy conversion, some energy always becomes less useful. This is because of something called entropy, which measures how disorganized or spread out energy is. Every process increases entropy or keeps it the same, but it never decreases. That means some energy is always lost as waste heat, making perfect efficiency impossible. Think about a simple heat engine, like a steam engine. It takes heat from a hot source and uses it to do work. But because the cold reservoir can never be at absolute zero, you can never convert all the heat into work. The maximum efficiency depends on the temperature difference between the hot and cold parts. Since the cold part can never be at absolute zero, the efficiency can never reach 100%. In real machines like power plants or engines, a lot of energy is lost as heat to the surroundings. For example, a typical car engine converts only about a quarter of the fuel's energy into motion. The rest escapes as heat. Friction and imperfections in materials also cause energy to be lost, reducing efficiency further. Even advanced systems like nuclear power plants or renewable energy devices can't escape these limits. Some energy always disperses as heat during each step of the process. This isn't just a technological problem but a fundamental rule of nature. So, the reason no process can be 100% efficient is that the second law of thermodynamics requires some energy to become less useful. The maximum possible efficiency, shown by the Carnot cycle, is always below 100% because of the temperature difference between heat sources and sinks. And in real life, friction, heat loss, and material imperfections make reaching that maximum impossible. Understanding this helps engineers design better systems, but they will always face these physical limits. The idea that energy is conserved is true, but its quality and usefulness always decrease in real processes. That's why no process can be perfectly efficient in thermodynamics.